Alright, welcome to another video. This is in the LPIC series. So, last video we finished creating the Anki cards that I will use in my retake strategy. So all the cards are here. Now this video, what I'm going to try to do is get through a day's worth of these cards. We'll see how long that takes, so I'm not going to spend any more time on an intro or anything. What are we at now? Yeah, we're not even at a minute, so I'm going to start this right away because I want a clear sense of how long this is going to take. This is great. I don't even know this. So the commands lspci, lsusb, and lsmod act as front ends to read the hardware information stored by the operating system. This information is kept in special files in the directory /proc, and I'm gonna go with /dev. Let's see if I'm right. Nope. See, this is why. So what I like to do is just use the agains and the goods. So these are all hotkeyed, short keyed. You can see here. So I'm gonna hit 1. There we go. And now this card we can see is in red, so it'll show me it more often than the ones that appear in green. So the next card, we just looked at this one, proc, so it's kind of unfair, but the last part of it is the proc directory /proc contains files with information regarding running processes and hardware resources. It's kind of a virtualized file system that shows you information about running processes and hardware resources that you couldn't see otherwise if it weren't in this like pseudo file system virtualized format. Alright, so that one's kind of an easy one, but it's a freebie, but I'm gonna mark it good. So another directory directly related to devices in a standard Linux system is I think this is the /dev. So those other ones was /proc, and then I can't even remember what it was, /sys. So /dev is another one. Every file inside /dev is associated with the system device, particularly storage devices. There we go. /media is another one, but I think that's for mounting file systems. This is for seeing information about the devices themselves. So I got that one right. So I'm going to hit 3. All right. So when looking for problems during system diagnostics, it may be useful to unload sysdig modules currently loaded. The command modprobe can be used both to load and unload. I think this is one. Yeah, I messed this card up. So let's do this. Let's edit this card. So we go here and then we go down here to the left, edit, and then I forgot to do this one correctly, so we'll fix that, and then I'll mark this one again. Okay, so it is the preferable way to interact with them is to use, which is a set list. This is so good. This is what I need. I'm gonna say lsblk. That's what comes to mind. There we go. lsmod. So that's the one I need to see again. Shows all devices currently connected. Oops, and there's my, if I want some sedentary time, I can have it. But I'm feeling good for now. Well, actually, to be honest, I'm feeling horrible. I am overdoing it. But anyways, shows all devices currently connected to the PCI bus. PCI devices can either be a component attached to the motherboard, like is this LS block? LSPCI. See, I'm not. This is perfect. Okay, so lists USB devices currently connected to the machine. Although this is LSUSB. Yeah. And the good thing too is as you do this, it'll show it in different orders and stuff. So this is perfect. Yeah, and this is /sys. I remember this. /sys and /prop are commands. Are special files and directories that the commands lspci, lsusb, and lsmod act as front ends for to read the hardware information that's stored. So I wish I could see more about which is which, but for now I think this is fine. lssys. So now that's no longer something I got wrong. I got that right. So I'm gonna hit 3 for good, and you'll see it still shows up as red. I still don't have anything in green. I have to get it right twice in order for it to move to green. All right, so the memories, I think it might be 3 times. You can actually adjust that parameter. I forget exactly how. Usually I have it, you have to get it right twice. It might be adjusted differently. Okay, so the memory space where the kernel stores its messages, including the boot messages, is called the kernel ring buffer. Messages kept in the kernel ring buffer even when they are not displayed during the initialization process, like when an animation is displayed instead, or this is all, or by executing. I don't know. I just don't know. So enter. There we go. DMESG. So everything I need to know. Perfect. I will pass this test. See what I mean? See how powerful this is? So in systems based on systemd, the command, I think it's journal CTL. Yep, journal. So JOURNAL CTL. So that was easy for me. This is a command for systems based on systemd, and it will show the initialization messages with the options -B, -sboot, -k, or -DMESG. So I knew this because initialization messages are what you see with journal CTL. So I get a good on that one. When looking for problems during system diagnostics, it might be useful to unload specific modules. So this is modprobe. The command modprobe modprobe can be used to both load and to unload kernel modules. It is common to have a large set of loaded kernel modules in a standard Linux system at any time. The preferable way to interact with them is to use the commands provided by the kmod package, which is a set of tools to handle common tasks with Linux kernel modules to insert, remove lists, check properties, resolve dependencies, and aliases. And this is lsmod, I believe, lsmod. The lsmod command, for example, shows all currently loaded modules. There we go. So I get a 3 on that. I get it good. Next question shows all devices currently connected to the PCI, peripheral component interconnect bus. PCI devices can be either a component attached to the motherboard, like a disk controller, or an expansion card fitted into the slot, like an external graphics card. So I'm pretty sure it's not LSBLK. Interesting. Yeah, I forget this one. So let's see the answer. LSPCI, okay. And then hitting again on that. So the this is easy, the BIOS. It says it right there. Yeah, BIOS, I'm... Yeah, and this is the UEFI. The UEFI is also firmware. It can identify partitions and read-minded file systems. Okay, and that's an advantage it has. It does not rely on the MBR. Taking into account only settings are stored in its NVRAM attached to the motherboard. The definitions, location, EFI applications. All right, so I can hit a good on that one. In order to control the machine, the operating system's main component, the kernel, must be loaded by a program called a bootloader. There we go. Yep, that's an easy one. So, which itself is loaded by pre-installed firmware, such as, so the UEFI or the BIOS loads the bootloader. The bootloader can be customized to pass parameters to the kernel, such as which partition contains the root file system, or in which mode the operating system should execute. Once loaded, the kernel continues the boot process, identifying and configuring the hardware. Lastly, the kernel calls the utility responsible for starting and managing the system services. That can be systemd. There'll be questions about those coming up next, so that's just good. All right, so this is DMESG. So the kernel ring buffer loses all messages when the system is turned off or by executing the command DMESG. Without options, the command DMESG displays the current messages in the kernel ring buffer. And the kernel ring buffer is the memory space where the kernel stores its messages, including the boot messages. DMESG. All right. In order to control the machine, the operating system's main component, the kernel, must be loaded. Okay, yeah, it was the kernel. It wasn't systemd, as I said before. I got that confused. Must be loaded by a program called a bootloader, which itself is loaded by a pre-installed firmware such as BIOS or UEFI. The bootloader can be customized to pass parameters to the kernel, such as which partition contains the root file system, or in which mode the operating system should execute. Once loaded, the kernel continues the boot process, identifying and configuring the hardware. Lastly, the kernel calls the utility responsible for starting and managing the system's services. Boom, kernel, got it. The blank is an archive containing a file system used as a temporary root file system during the boot process. The main purpose of a blank file is to provide the required modules. I think I'm going to go with /proc on this one, /proc. The C got this one completely wrong. So it's initramfs. So the initramfs, and which makes sense because file system stands for file system. FS stands for file system. The initramfs is an archive containing a file system used as a temporary root file system during the boot process. The main purpose of an initramfs file is to provide the required modules so the kernel can access the real root file system of the operating system. So got that wrong for sure. Shows all devices currently connected to the PCI. Okay, this one I have now. It's LSPCI. All right. So as soon as the root file system is available, the kernel will mount all file systems configured in /sc/fstab, and then we'll execute the first program, a utility named systemd. And it. Okay. One thing. So that's again one thing that I said wrong earlier too is these won't show up in the green when I get them right. The reason they show up in the green is because they're ready for review. So red is you got them wrong, so you need to do them until you get them right, and then they'll leave the red queue. Blue, of course, is new cards. So when you see a new card and mark it, whether you got it wrong or right, it'll go into the it'll either go into the red queue or it will just disappear. It won't be added to the green queue. The green queue will see that populate tomorrow because those are the cards that it needs, that it will show me again based on the cards I got right or wrong. It will show me the ones I got right less often than it will show me the ones I got wrong. So next question, on systems based on initv, Oh, sys5 init. I think that's a Roman numeral. So sysv init, sys5 init. Got it wrong. So blank is a modern system and services manager with a compatibility layer. Has a current structure. Is this systemd? What is systemd? Oh, this is systemd. So systemd is a modern system and services manager with a compatibility layer for the sysv commands and run levels. Systemd has a concurrent structure, employs sockets and dbus for service activation, on-demand daemon execution, process monitoring with C groups, snapshot support, system session recovery, mount point control, and a dependency-based service control. In recent years, most major Linux distributions have gradually adopted systemd as their default system manager. So that's good for me. I'm going to do good. So during system installation, the init program identifies the requested run level, defined by a kernel parameter or in the something file. All right. And loads the associated, well, we know this one, right? It's going to be /etc/fstab, FSTAB. Oh, no, wrong. /etc/init tab. And tab probably stands for table, so kind of makes sense. Didn't get that one right. On to the next one. The blank command adds extra functions to the power off process. It automatically notifies all logged in users with a warning message in their shell sessions, and new logins are prevented. Command blank acts as an intermediary to sysv or systemd procedures. That is, it executes the requested action by calling the corresponding action in the services manager adopted by the system. Dang. I guess shutdown? Yeah, well, got it. Yeah, because it to the power off process. Okay, got it. So the blank is an archive containing a file system used as a temporary root file system during the boot process. The main purpose of I think this is a init ramfs. Yeah, okay. So init ramfs, init ramfs. So I got that one good now. Okay, so on to the next one. As soon as the root file system is available, the kernel will mount all file systems configured in /etc/fstab, and then we'll execute the first program, a utility named init. Perfect. During system initialization, the blank program identifies the requested run level, defined by a kernel parameter or in the /etc/init tab file, and loads the associated scripts listed there for the given run level. And this is sys5 init. Oh, sorry. Init was the correct one, so I got that wrong. Another directory directly related to services in a standard Linux system is blank. Every file inside blank is associated with a system device, particularly storage devices. This is /dev. There we go. So we can see it used to be 20, it dropped down to 19. That card is now completed for the day. It'll come back later as a green card, but it'll come back in a frequency dependent on how easy the card has been for me to get right. So on systems based on blank, init is the first process that is executed once the Linux kernel loads. I'm going to say sysv init. There we go. All right, so this is /proc. Kind of information is kept in special files and the /proc. Got it. /proc directory contains files with information regarding running processes and hardware resources. So processes, proc, that's probably where it comes from. halfway through. Let's take a look at the clock. And I'm not exactly halfway through because I got to get through all the red cards as well, but 20-minute mark, so this is going to take quite a bit. The program responsible for managing run levels and associated daemon/resources is /sbin/init. During system initialization, the init program identifies the requested run level, defined by a kernel parameter or in the /sc/init file, and loads the associated scripts listed there for the given run level. Every run level may have many associated source files, usually scripts in the blank directory. I'm going to go with /lib. Completely wrong. So it's /etc/init.d. As not all run levels are equivalent through different Linux distributions, a short description of the run level's purpose can also be found in sysv-based distributions. So definitely an again on that one. During system initialization, the init program identifies the requested run level as defined by a kernel parameter or in the blank file. So I just don't know. Okay, so it's /etc/init tab file. Okay. All right, and I'm going to take some sedentary time. I need it really badly. All right, so on to the next question. Lists USB devices currently connected. This is LS USB. Got it. During system initialization, the blank program. Yep, and remember this from earlier. So this is the init program. Got it. The same init program can be used to alternate between run levels on a running system without the need to reboot. The command, interesting. Okay, I don't know. I think it's a new card. Yeah, tell init. So do again, and yeah, that was a new card I haven't seen before. So currently, blank is the most widely used set of tools to manage system resources and services, which are referred to as units by, isn't it systemd? Oh, I guess there's two systemd cards. All right, so I got that one right. The main command for controlling systemd units is, I just saw it and I forgot it. Command blank is used to execute all tasks, unit activation, deactivation, execution, interruption, monitoring, etc. Isn't it just systemd? Systemctl. All right, so systemd is also responsible for triggering and responding to power-related ASPCI. Oh, sorry, ACPID is what I meant to say. That's just the first thing that came to mind, but that's not the question. Power-related events. When I saw power-related events, the first thing that came to mind was ACPID, which is great because there was a certain circumstance not too long ago where that was not the first thing that came to my mind at all. The systemctl suspend command will put the system in low power mode, keeping current data in memory. The command systemctl hibernate will copy all memory data to disk, so the current state of the system can be recovered after powering it off. The actions associated with such events are defined in the blank /lognd.conf or in its separate files inside the blank /lognd.conf.d. However, this systemd feature can only be used when there is no other power manager running in the system, like the ACPID daemon. The ACPID daemon is the main power manager for Linux and allows finer adjustments to the actions following power-related events like closing the laptop lid, low battery, or battery charging levels. I don't know. It's a new card, so let's see what the answer is. So it's /etc/systemd. In systems based on systemd, the command journal CTL. Yeah, this is one I actually know. All right, so, and then this is /sys. Got it. BIOS, this is an easy one. Okay. When looking for problems during system diagnostics, it may be useful to unload specific modules currently loaded. The command unmount. Mount. Or is it mod probe? That's what it is, mod probe. NODPROBE is my answer. Got it. All right, and you could get more granular with it. I could give it a 2 instead of a 3, but I think getting too sophisticated just overcomplicates it. So the program responsible for managing run levels and associated daemons/resources is /sbin/init. During system initialization, the init program identifies the requested run level, defined by a kernel parameter or in the /etc/init tab file, and loads the associated scripts listed there for the given run level. Every run level may have many associated service files, usually scripts in the blank directory. As not all run levels are equivalent through the Linux distributions, a short description of the run level's purpose can also be found in sysv-based distributions. So I feel like I just got this one. I'm going to say /etc/init.d. Aha, I got it right. So /etc/init.d. It's a directory. So there's an ending slash, but that's I got it right. During system initialization, the init program identifies the requested run level, identified by a kernel parameter or in the okay, so it's a file or in the something file and loads the associated scripts there for I just don't know. Okay, so /etc/init tab. So this one is really if I hadn't been doing these cards, I would definitely get any questions about that wrong on the exam. So good thing I'm doing these cards. This one is UEFI. That's kind of a freebie. So lists. So this is LSUSB. That's an easy one as well. During system initialization, the something program. So this is the init program, INIT. In order to control the machine, the operating system's main component, the kernel, must be loaded by a program called a bootloader. The same init program can be used to alternate between run levels in a running system without the need to reboot. The command blank can also be used to alternate between run levels. I just had this one. I honestly, I don't know. Oh, telling it. Okay. It is common to have a large set of loaded kernel parameters in a standard Linux system at any time. The preferable way to interact with them is to use the commands provided by the kmod package. I think lsmod. There you go. So the command lsmod, for example, shows all currently loaded modules. All right, got that one right. So I can hit a 3 on my keyboard. The main command for controlling systemd units is systemctl. All right, and this is dmesg. Yep, this is for kernel ring buffer messages. You can use DMESG to clear them out with --clear, or you can just display them by entering it without any options. So that's a number 3. Systemd is also responsible for triggering and responding to power-related events. I'm gonna go with /etc/systemd. Got it. Okay. Alright, so it shows all devices currently connected to the PCI, LSPCI. The configuration files associated with any units can be found in the /system directory. The command systemctl, so we know it's a systemd related thing. So I'm going to do So where do files go? They go in. So I'm /lib/systemd. Let me try that. Hey, I got it right. That's awesome. So I got it right just based on inference. I didn't have this memorized, but I knew that configuration files associated with programs can be in -lib. I mean, yeah, system-wide configuration files go in /etc. And then yeah, I knew it was systemd because of systemctl. So hey, and my intuition is starting to become developed. In order to control the machine, the operating system's main component, the kernel. During system initialization, the init program identifies the requested run level, identified by a kernel parameter, or in the now we can do the same thing. Now this is a system-wide file, so it's /etc. I'm going to go with /etc/init.d. Oh, no, it's a file. Init.d is a directory. So, /etc/init. Let's go with that. Init tab. Okay. I'm getting closer. Similar to what the shutdown command does when powering off or restarting the system, the blank command is able to send a message. Wall. I just know what this is. I just know what it is because I've used it in the real world in a way where, like, I know what it is. Alright, so the same init program can be used to alternate between run levels in a running system without the need to reboot. The command blank can also be used to alternate between levels. So it's telinit. Init. T-E-L-I-N-I-T. Telinit. T-E-L-I-N-I-T. Telinit. Got it right. There may even be performance reasons to keep certain directories on separate partitions. You may want to keep the blank on a speedy unit, and bigger directories like /home and /var on slower. I'm going to go with /etc. Okay, the root file system, which includes /etc, includes the boot. So, got that one wrong. This directory contains variable data or files or directories the system must be able to write to during operation. /var. Yep. /var var. Yep. So good. A blank is a modern system and services manager with a compatibility layer. I'm going to go with systemd. There we go. The standard parent directory for home directories on users. Parent directories for a parent directory. /root/usr. Oh, sorry. /home. Got it wrong. The blank is an archive containing a file system used as a temporary root file system during the root process. The main purpose of an blank file, we got a hint there, is to provide the required modules. /etc/fstab. No. the blank command adds extra functions to the power off process. It automatically notifies all users. This is the shutdown command. Got it. During system initialization, the init program identifies the request one level, defined by a kernel parameter or in the init ram fs file. Init tab. I keep getting this one wrong, which is good. It'll keep asking me about it until I get it right. So on systems based on sysv init. Yep, got it. As soon as the root file system is available, the kernel will mount all file systems configured in /etc/fstab, and then we'll execute the first program, a utility named init. There may be performance, and the cool thing about this too is like this is like really transferable knowledge. So like when you think about a Python class and you do the dunder method within the class, so __, init __, it's the same thing. Like it's happens to, it's similar to this in a way. There may even be performance reasons to keep certain directories on separate partitions. You may want to keep the blank on the root file system. So the root file system specified with. Oh wait. /root. You may want to keep the /root. Yeah. So. Oh no, the / file system. This question I'm not so sure. Let's have it cleaned up by the AI. I think it'll make more sense. So is this a good and clear question with a good and clear answer? Okay, so I was confused and got it wrong because my answer was, instead of, my confusion was that I thought by the answer being that you couldn't separate child folders of such as and var. What is incorrect about my understanding? Let's get the voice.
Your confusion might stem from the fact that / the root file system, is the top-level directory that contains all other directories, including /home and /var. While it is true that all directories are children of /, you can still separate child directories onto different partitions or drives. For example, you can have the root file system, / on an SSD, while /home and /var are on separate partitions that are mounted to those directories. This way, when you access a file or directory within /home or /var, you are actually accessing data on a different partition or drive. This is commonly done for performance reasons, as well as to simplify backups and system restoration processes. So, in summary, while all directories are technically children of /, you can still separate them onto different partitions or drives for various benefits.
Okay, so if you think of this like a tree isn't really the trunk, right? Because I guess you could think of it being the trunk and everything. Okay, I'm satisfied with this. So let's stay on topic. 40 minutes in. So if this is a 40-minute exercise, it's going to be difficult. I got this one wrong though, so we'll do it again on it. So the standard parent directory for home directories of regular users on a system /home. Yep. The blank is an archive containing a file system used as a temporary root file system during the boot process. The purpose of a blank file is to provide the required modules so that the kernel can access the real root file system. I don't know. Init RAM FS? Hey, I got it right. Okay. I got it right, so we'll do a good on that one. Yeah, because it's from the RAM. It's not, it's an archive containing a file system used as temporary root file system during the boot process. So the main purpose of this file is to provide the required modules so that the kernel can access the real root file system of the operating. So it's like showing you what's going on in the RAM, because what goes on in the RAM happens first, as far as I understand. During system initialization, the init program identifies the requested run level defined by a kernel parameter or in the blank file and loads the associated scripts listed there for a given run level. The blank file. I think this is telinit, TELINIT. Sorry, got it wrong. So it's /etc/init tab. Currently, blank is the most widely used set of tools to manage system resources and services, which are referred to as units by blank systemd. Got it. The program responsible for managing run levels and associated daemon/resources is /sbin/init. During system initialization, the init program identifies the requested run level defined by a kernel parameter or in the /etc/init tab file and loads the associated scripts listed there for the given run level. Every run level may have many associated service files, usually scripts in the blank directory. I'm going to go with /etc/system/init.d. Yep, /etc/init.d. Got it right. As not all run levels are equivalent through different Linux distributions, a short description of the run level's purpose can also be found in sysv-based distributions. There may even be performance reasons to keep certain directories on separate partitions. You may want to keep the blank on a speedy SSD unit and bigger directories like /home. Okay, so that's just the slash with nothing else. So the root file system, which is just that slash. It's not /root, it's just a slash. Okay, this is LSUSB, easy one. During system initialization, the init program identifies the requested run level defined by a kernel parameter or in the blank file and loads the run level telinit, TELINIT. I keep getting this. Wow, I'm bad at that one. Okay, so during system initialization, the blank program, this is the init program. Init, got it. The main command for controlling systemd units is blank systemctl. Got it. During system initialization, the init program identifies the requested run level. Okay, I know this one now. It's /etc/init tab, TAB. /etc/init tab. So, yeah. It's a table. It loads a table. All right. Systemd is also responsible for triggering and responding to power-related events. The systemd suspend command will put the system in low power mode, keeping current data in memory. Command systemctl hibernate will copy all memory data to disk, so the current state of the system can be recovered after powering it off. The actions associated with such events are defined in the blank file /etc/systemd. Got it. Because this is like system-wide configuration, so it's a configuration file, of course. It's got a directory with more configuration files in it, so easy. The configurations files associated with every unit can be found in the /etc/systemd again. /lib. God damn it. That's frustrating. Similar to what the shutdown command does when powering off or restarting the system, the blank command, wall, easy one. The configuration files associated with every unit can be found in the /etc/systemd. /lib. I keep getting this wrong. So the system-wide configuration files are in etc. The configuration files related to specific programs and files within those programs are in /lib. This directory contains variable data /var. The configuration files associated with every unit can be found in the... Now they're associated with the unit, so these are not system-wide configuration files. These are configuration files associated with a specific program. Those go in /lib, not in /etc. So the answer is /lib/systemd. All right, and I'll take my... I'm tempted to just skip it because I'm trashing myself. It's just been a complete shock to my system to go from completely sedentary and having a lifestyle, somebody who's like really obese, to like having an active lifestyle. I'm in pain. Help me. All right, well, let's continue. So the same init program can be used to alternate between run levels in a running system without the need to reboot. The command blank can also be used to alternate between run levels. I should know this one. Man, I should know it. I think it's telinit, TELINIT. Got it. The blank is an archive containing a file system used as a temporary root file system during the this is a knit/ram/fs. All right, the standard parent directory for home directories /home. During systemization, the init program identifies the requested run level defined in the kernel by a kernel parameter or in the /etc/init tab. Got it. There may even be performance reasons, so you want to keep the root, which is just the /. It's not /root. It's just /. There we go. I guess it could be either. I don't know. I think it's I don't know. The configuration files associated with every units can be found in the... Now this is with a unit associated with a particular program, not system-wide, so it's /lib/systemd. There we go. Hey, good news. So it took about... Should allocate about an hour if I... With the review cards, because we didn't have any review cards this time, so I should expect to take it about an hour every day. That's about what I've been doing so far, so not too bad. Let's make sure that the progress is synced up so that there aren't any issues with that. And yeah, that's the end of this review session. So thanks for watching and see you in the next one.